Okay, so today we're going to talk about endosymbiotic theory. First, we need to define what is a theory. Earlier this week, we talked about cell theory. Other examples of scientific theory include atomic theory and the plate tectonic theory. You'll learn more about this one in chemistry. Plate tectonics, you talked about last year in middle school. Should have, yes? Okay. So you don't need to rewrite this part, the what is a theory part. Don't need that. You already had that on the front. But our definition of theories, when we use that word in science, we are talking about things that are based on natural and physical phenomenon and are capable of being tested by multiple independent researchers. Theories are going to be are well established and highly reliable explanations. So on Monday was when we talked about cell theory, and we looked at about 200 years of scientists who had researched on it to develop modern cell theory. The atomic theory, when you take chemistry next year, you'll spend some time talking about how it was developed and the changes that it's been through. They're all well established and highly reliable. And the examples on the front are more foldable. The theory of plate tectonics. That one is relatively new. It was published and became accepted in the early 1970s. The title? Endosymbiotic theory. So we're going to put it at the very top of the page also. The focus of our notes today is the endosymbiotic theory. This theory helps to explain how we got organelles, things like mitochondria and chloroplasts. So here in this picture showing the process. Here we had a bigger cell, brought in a smaller bacteria or prokaryotic cell. So this cell was making lots of energy. Big cell protects it. Little cell makes energy for the big cell. And over 1 million years, we get mitochondria. Symbiotic, we talked about symbiosis, where things benefit and live together. So that's where the name comes from. All right. We're going to break that up. So endosymbiotic theory, it explains how eukaryotic cells got their membrane-bound organelles, specifically the mitochondria, so the powerhouse, and the chloroplasts. Chloroplasts are the cells that do photosynthesis to make the glucose, to make the food. This theory was first proposed in 1967 by a biologist. Her name was Lynn Margulis. Dr. Margulis took research from a lot of different scientists, not just her own, to develop this theory. It explains how a large host cell and an ingested bacteria could easily become dependent on one another for survival, resulting in a permanent relationship. Some of the evidence that Dr. Margulis used to support this is both our mitochondria and our chloroplast. They have both an inner and an outer lipid bilayer. So they have almost two cell membranes to them. The chloroplast and the mitochondria are similar in size to prokaryotes and other bacteria. Chloroplasts and mitochondria both reproduce on their own, and they reproduce in a fashion that's very similar to how bacteria reproduce. And mitochondria and chloroplasts have their own unique DNA. You find DNA inside of them, and it's different from what's in the nucleus of the cell.